All right, let's write it down. Looks fairly easy to do, by the way. It's going to be x cubed over 3 minus 2x squared over 2, which is x squared, plus 2x, limits of integration, minus 1 to 3. Let's do the arithmetic. What are you going to get? Well, let's see. 3 cubed divided by 3 is 9, minus 9, plus 6, minus, oh, got to do the lower limit, right? Minus 1/3. Let's see, minus 1, minus 2. All right, let's take a look at that. You can get 6. Let's see, plus 1/3. That's going to be minus 3, so plus 3. And that's going to be 9 plus 1/3. That's going to be 28/3. All right, let's get our red pen out. Let's look at the key, and let's hope we got a right answer on that one over there. By the way, I wanted to say, oh, I'm sorry. I did the evaluation, but they want me to do it by doing a Riemann sum. I know I'm going to get 28/3, by the way. That's good. I know I get 28/3. All right. So what I want to do is go in for the Riemann sum, and what I'd recommend do is, especially in an exam, is try to write these things down quickly. All right. So what's it going to be? Well, let's look at the integral, and the integral goes from minus 1 to 3. So the partition length is 4. We divide it into. Whoops, sorry about that. We divide that into n equal parts, and then I do what's called a right endpoint, and I think they said right endpoint. Yeah, it's the easiest way to do it. So it's minus 1. You keep nudging yourself over for n, and I will go from 1 to n. Then what do you got to do? And it's trouble. I know it's trouble. You got to take this thing here, and you got to plug it into the function. And someone says, what function are you talking about? This function. Right? Does it require work and effort? It sure does. After you do that, then you got to multiply through by that, and you should be able to get this over here. All right? Then what do? You do the sum. And what's nice about the sum, it's really not a bad sum to do. All right? And and the reason for that, there's a couple of easy things over here. I want to point out the sum of the squares, just some of the integers, and that's a constant. What's that going to be? 20 over n times n. Well, that's relatively simple. That's just 20. This over here, the second guy is 64 n squared. You would get, let's see, n plus 1 over 2. That gives you, what, 32. One of the n's cancel. Yeah, you get the idea. And then the square formula, if you can remember it. If not, you got to derive that. And then what do you get? You get it simplified. And after you get this simplified, it does work out pretty nice. Something like this over here. Then what do? Let n go to infinity of the simplified form of that, and you're going to get 28/3 or 9 1/3. By the way, I know I started the problem off doing the simple thing, use the fundamental theorem, but you should be able to do a right endpoint Riemann sum, and that's all we did there. Thank you.